Welcome. In this session on natural deduction, we'll briefly explore some ways of expressing logic and what consistency of logic means. Historically, mathematical logic preceded natural induction by about 45 years. The original intent of mathematical logic was to formally prove statements in logic and mathematics. Eventually, it's usually expressed using 3 axioms and 1 inference rule. The first axiom is one that we've already seen, which is that a true formula is implied by any other formula. The second axiom is more complex. It's often referred to as the monotonicity of material implication. It states that if a formula implies another implication, then that antecedent formula can be distributed across the consequent implication. The third axiom more or less encodes our form of proof by contradiction. The only rule in mathematical logic is the rule of modus ponens, or implication elimination. After about 40 years of use, it was shown that these axioms are consistent. That is, using these axioms and this proof rule, we cannot arrive at a contradiction. Now, let's turn to natural deduction. The idea of natural deduction, which came a few years after the demonstrations for mathematical logic, was instead of trying to prove statements, it was trying to formalize methods of proof in both logic and in mathematics. As we've seen already, there are no axioms in natural deduction, so it's a very different way of reasoning. There are 12 rules in the classical logic, plus we sometimes need to add the copy rule. Let's take a look at what consistency means. In terms of an axiomatic system, consistency means that there are no contradictions. In terms of natural deduction, what we can say is a remarkable thing, and that is, this is a proof about a logic, and that is that it is false that there exists a proof of the sequent with no premises whatsoever. We can derive the bottom symbol. And by a proof, we mean a proof of finite length, that is, with a finite number of steps. And it was shown shortly after the invention of natural deduction that natural deduction was consistent. And that's an important thing, because if we were ever able to use the rules of deduction and we were able to prove the bottom symbol, then by bottom elimination, we could prove anything at all. So by proving that there is no proof of the bottom symbol, that is, it's impossible to arrive at a contradiction, this is not a proof within natural deduction. This is a proof about natural deduction. And so we say that this is a metalogical proof, where meta is the Greek word for about, and a metalogical proof is a proof about a logical system.